Hello and welcome. This is Robotics in Offshore Renewables Live. So I'm Alex Loudon. I'm an Innovation Manager at the Offshore Renewable Energy Catapult. We are the UK's flagship technology innovation and research centre for offshore renewable energy. And our role is to support the development of a vibrant UK supply chain and provide a clear route to market for innovative companies and technologies. And that invariably involves leveraging in expertise from the UK's world-leading academic research base. The UK is also a world leader in the development of robotics, and today we're going to explore how these two innovative and exciting technologies come together and support each other in order to create UK economic benefit and drive job creation. So today we're very lucky to have three people at the forefront of these two sectors, world leaders in both robotics and offshore renewable energy. And so without further ado, I'll let them introduce themselves. Sara.
Hi, my name is Sara Bernardini. I am a professor in artificial intelligence at Royal Holloway, University of London, and my area of research is intelligent autonomous systems for extreme environments. And in fact, I'm now involved in a project with the Catapult that is about developing the world's first fully autonomous robotic platform for inspection, maintenance, and repair of offshore wind farms.
Iain.
Hi, I'm Iain Wallace. I'm the Chief Scientific Officer of Rovco. We're a UK company that's pioneering subsea robotic inspections and applications of AI to data analysis. We've developed a series of subslam camera systems that combine computer vision, machine learning, and AI, and autonomy, and also an intelligent data platform for delivering the results of our inspections to end users. We also work with a Catapult, and we're both a sort of technology developer and a service provider.
Hi and good morning. I'm Anthony Gordon, working for GE Renewables Offshore Wind. I'm the Steershore Program Manager, which is responsible for bringing new digital and robotic techniques and operations to our wind farms, with obviously the ultimate aim of reducing risk, manual and repetitive tasks, and hopefully cost as well. And it's also doing that by driving automation into our supply chain and operations.
Thank you very much. So over the next hour, we're going to have hopefully a very lively discussion about offshore renewables and robotics. But there will be an opportunity to ask questions for the last half hour of this live stream. So please do get your thinking hats on, and I'll be able to ask questions to our panel today. So I think the logical place to start is why robotics and offshore renewables. And I think a lot of the time, dull, dirty and dangerous is often cited as the reasons why robotics might be suited to a task. And certainly there's a lot of that in offshore renewables. For instance, we have rope access inspection teams abseiling down blades. We have a lot of diver-led operations. So interested to get kind of open thoughts from the panel to start with on why robotics and offshore wind. Do you agree with those reasons? Do you think there are further reasons?
Thanks, Sarah. I think the why is interesting, but I think the real question is when. So the discussion I have with a lot of people in this industry, especially if someone's maybe being a bit conservative, I kind of start by saying, well, at the moment we're sending people out on boats who, in my business, are staring at video screens, driving remote control submarines around. That's clearly not the future. People hanging off blades is clearly not the future. You know, the future, the robot submarines drive themselves. It's not people staring at the video screens. It's computers watching the data. It's not people dangling off wind turbines. It's robots flying around, right? This is the future. In 100 years' time, we're not doing things the same way. And I think anyone would agree on that. Anyone watching would agree on that. So then the real debate is when. Right. So when does the change happen? What change happens when? And then to get to your why is that change driven then? So I think for me, that's the interesting question. So I would kind of say to my other panelists, think about like the when and what drives that change then is the actual interesting bit there. So yeah, I don't know if anyone's got thoughts on that. Or do you disagree with me that eventually that's the future?
No, I don't disagree. I think that when is an important question because working in this industry, I also experienced some resistance from the operators in wanting to use this technology and trusting the technology. So I guess our job is to make technology robust enough that can be trusted by the operators, and then they can feel still in charge of the mission, even if they are not there, but they remotely control the mission. And so this is what I'm trying to focus on in my research, to develop robust autonomy technology so that operators will be able to feel they own the mission if they are not there in person.
Okay, so I guess you're looking to provide the why to the when, if you like. Why now? Because we trust it.
Yeah.
Okay. So I guess you maybe have a different input on this as to why are you?
Yeah, again, I think because obviously the program I'm looking after, it's kind of the key message of let's kind of look at that, and it's obviously looking at the risk you want to eliminate and reduce it as your first kind of options, and I think that's what robots can do potentially. It's the elimination to humans of that risk of hanging on ropes, going into those kind of dangerous confined spaces, etc. And it's you're eliminating that kind of element to it. I think the when topic's actually quite interesting because again, it's when are people ready as well for this? I think there's obviously resistance potentially to change, and that kind of also pushes it there. But yes, I think as well you've obviously got a push from people of you want to be smarter with what you're doing as well, and I think robots allow people to be smarter with what's happening, and you take away that to then focus on other tasks which are more value add in the kind of offshore environment.
Yeah, so I guess for us the why robots, partly the safety case. Sometimes you have to, right? If you're 6,000 meters deep, you can't send a person. But for us, one of the big drivers, or we see for our customers, is efficiency. Like people turn up for efficiency, they're looking for efficiency, fewer vessel days. But I think going forward, the real reason, the real why will be quality. You can achieve a different quality, a different reliability. I always think about reliable, repeatable metrics. That's what people want, and that's what robots can give you. And that speaks to your point on partly on risk, if that's risk to the asset as well. Mm-hmm. And then I think going forward, also regulation and safety, I think are interesting points that will drive it. Either the safety case drives the use of robotics or regulation, which either leads or follows.
I think we might come on to that a bit later on as well in a bit more detail. But and I guess all three of you are looking at this in slightly different timescales. As an academic, Sara, I guess naturally you're looking at slightly further out technologies. Iain, you're looking to commercialize in the short to medium term, and I guess GE are looking to provide value to your customers almost immediately or in the very short term. So do you think that changes the drivers behind the adoption of robotics? Do you think those different timescales have an impact?
I can go in again. This I think to some extent, yes. I mean, so I'm Chief Scientific Officer of Rovco. I'm focused on what is now possible, and I glibly describe what I do as working on stuff that's neither academically interesting nor practically useful, right? Of course, it's about bridging the gap, right? Taking the stuff that is academically proven, making it practically useful, and seeing where we can put stuff to work. So yeah, we are focused on, in some stages we're developing the technology, it's kind of midterm, like you say, and some stuff is stuff we can do now. It's often not as black and white as all that, right? I mean, I can give examples of what we do. Our camera system lets us get lovely 3D data underwater, right? And from the long-term perspective, it's a camera system that can understand the world around it and knows where it is. This is clearly a core component of a future autonomous system, a robot that knows where it is and can navigate. If I flip it the other way and say near term, the benefit to our customers is we can measure things underwater. And you get back to like risk and inspection, what customers want. They want, they might commission a video survey, but the actual thing they want to know is how far apart is that? Has that moved since last time? Is this installed correctly? So yeah, I think it's a real sliding scale, but we're always looking for things that can be commercialized in the near term or ideally useful now, and then also feeds into the future.
So, Sara, how do you approach looking at what people are going to need in the future, longer term?
Yeah, as I said, I am involved in this project with the Catapult Memory. It's called, and this is a very ambitious project because we are trying to develop a fully autonomous robotic platform that will do inspection, maintenance, and repair. And there is nothing like that out there, and so it's very difficult to create a comprehensive and fully integrated integrated multi-robotic platform. And so our challenge is really how to coordinate different and heterogeneous robots, how to involve the operators in such a way that, as I said, they trust the technology. And also, of course, each robotic assets need to perform sophisticated tasks. So we have the coordination issue, but we have also the efficacy of each robotic asset. So this is a 2-year project, so but we feel that we have to work on this for a few years more in order to achieve our final goal. But I think that the different pieces are there. It's a matter of putting them together to create, a fully integrated system.
Sure. And Anthony, where do you think we are now, as of today? Is GE actively utilizing robotic technologies already, or is the Stay Ashore program more about looking at how they can contribute down the line?
It's looking at how they can contribute down the line, and obviously trying to bring those into our operations and looking at what we can do. So I think it's very much considered in the roadmap for what we're looking at. But it's if we can bring something now, brilliant. If not, we've obviously got that program over a number of years to review and implement and see what we can bring.
Mm-hmm. And so moving on a little bit, so Sara and Iain, you both have a shared past working in the space sector. How has that experience enabled you and helped you working in offshore, which is a very, very different environment by all accounts, but presume there must be a huge amount of transferable knowledge and skills?
Yes, for sure. Like my area of research is AI planning. And so this is about how like a robot or an agent, starting from an initial situation, plan to reach a goal. And so this is really general purpose technology that can be applied across different sectors. So as you said, I started with space mission operations that also clearly require full autonomy. And then I transferred this to completely different topics, like, for example, even virtual agents to work with children, to develop social skills, and to extreme environments. And so it is the same technology, the same algorithms, but what it changes is how you model your problem and the initial specification of your problem. So I could reuse a lot of the techniques I developed initially for NASA.
Yeah, I mean, for me, it's how I got into working in offshore is a lot of it is exactly the same problems. I mean, it's not kind of obvious. I mean, previously I was doing field trials in the Atacama Desert, which is the driest place on Earth, and now I'm putting robots underwater. It seems like it would be the opposite, but a lot of the problems are actually the same. You've got inaccessible location. You can't or you don't want to send a person, so you're sending a robot. It's very hard to do any maintenance to a robot. You have very low bandwidth connections. You can't get data off it. So it absolutely must be reliable. Absolutely must be well tested. And it wants to see and understand its surroundings well. It wants to capture good data. It wants to it wants to somehow distill that and get it back for human analysis. A lot of these problems are very common between the two. And I think in some ways it leads the way. It suggests how things might be done. I remember being at an event, offshore robotics event, and someone was asking the question, how can we reliably operate robots for months at a time remotely if we can't, get access to turn them off? And it's like, well, humans have put robots on Mars for tens of years and no one could go and turn them off and on again, right? So there is a model for how it can be done, and there's maybe something to go out there. And I think more specifically in terms of the way that what I would think of as semi-supervised autonomy is done, like Sara mentioned, the planning. So a big part of how Mars rovers get operated is you create a plan for the day, the robot executes the plan, and then you get the data back. And I can see that because of the restricted communication subsea, specifically, and even if you're not subsea, even if you're looking at the top side, you don't always, with weather and so on, guarantee high bandwidth links. I imagine similar strategies will be used. So I think there are a lot of parallels. There are, of course, differences too I could get into, but it's...
The wet for one.
Yeah, the wet for one. In some ways, a harder environment in space.
Wow, yeah. So, Anthony, from GE's perspective, how do you start to think about planning robotics into future service offerings? You mentioned that it's very much in line with your roadmap. How do you start to think about bringing these new technologies through into what is part of a wider offering to the industry?
Yeah, again, I think it's the consideration of the program. We're looking at robotics and what tasks they can take, and as I kind of mentioned, it's repetitive service tasks. What can be replaced with robotics? And I know Iain mentioned obviously some of the items such as people hanging off ropes and what the future looks like, and kind of that risk element as well, taking that away. So I think it's very much looking at that out on the roadmap and where they can go. And I think as well, kind of digitalisation and analytics is kind of one of the next big phases. It's obviously kind of already being looked at, and it's obviously a focus for GE and others. So I think that's kind of one of the next stages as well, is that.
Yeah, and I think you mentioned there that certainly GE aren't the only large company looking at these types of things, and I think that's what we're seeing, is that it's very much the when, not the if, that Iain mentioned at the start. But there's robotics has the potential to generate huge amounts of data for the customers. Do you think this provides a challenge to them? What are they going to do with all this data? Or do you think it's actually an opportunity if they've got the chance to understand significantly more about their assets and about their structures to make better decisions?
Well, I guess it's both. So clearly, to do machine learning, you need a lot of data, and the more data, the better. So we see it as an opportunity. However, clearly, the data themselves don't give you much, right? So you need to have the technology in order to extract knowledge from the data, and that's not always straightforward. And also, in our project, for example, we try to do a lot of processing on offshore and send onshore only valuable data for the operator, because we want to be careful in not overloading like the operator with too much data. So yeah, I mean, it's an opportunity to understand better the situation, and for the robot to have a full awareness of what is going on, what they need to do next. But at the same time, the amount of data needs to be managed well to analyze them, and also not to transfer too much data to human operators, and only valuable data.
I think it's interesting to talk about the data point, and also to go back to what you were saying about how you're planning the introduction of robotics, and you're talking about the things robots do. It's easy to think of robots and autonomy just as the moving bits of metal, right? Like, how does a robot? But that's not most of the job, right? If I think of an offshore inspection, you've got a large vessel with lots of people in the boat. There's only a couple of people driving robots at any one time. There are far more people looking at the data. And the data in a lot of cases is the product, right? It's someone pays for a survey or an inspection, but what they actually want is the data that comes out of it. And so that's for us, a lot of our focus is on that. It's their data platform, is how can we take this data, how can we process it? And you talk about things that robots can do better in terms of risk, but it's you mentioned dull, dirty and dangerous. It's the dull. Like my favorite phrase around this is computers have like a superhuman capacity for tedium, right? You can ask them to do super boring jobs that can give you new insights. So things like count all the bolts on my structure, watch this video, And, I think maybe to put a question to the audience to have them to think about for their questions later is the question I always think is, what would you ask of your wind farm, say, or your turbine or your monopile that you can't answer at the moment because either you can't get the data or it's too boring to do it, but it is a useful metric. And
I think that tedium point is really important as well, because humans have a very known capacity to make mistakes, especially if they're asked to do the same thing over and over again. So actually, that quality piece that you mentioned earlier comes in a big way there, doesn't it?
But this also speaks to risk, and like one of the advantages of like when you say data, but you need the data to understand the problem. You need to also, in some cases, measure human performance. So in terms of the industry appetite for autonomy and robotics technology, a lot of it is around risk. People don't want to try the unknown thing. But offshore in some ways is a good industry applying it, because there's a culture of managing risk, right? People like it if they can understand the risk, they can put mitigations in place. So in this case, it's about proving performance. So you mentioned the human performance, and that's an interesting one, because that's often where there's not actually good answers. If I'm saying, oh well, a surveyor can review this video, or we can review this video with an AI system. People say, well, how good is the AI? And I say, well, yeah, we can tell you how good, but how good is your human? And are they that good an hour into their shift with a fresh cup of coffee as they are 8 hours in?
Yeah.
Maybe not, I'd say. But that can be a managed risk. So I'm not saying there's anything wrong with humans. I'm just saying that's a known, understood managed risk, and we'll need the same thing. And to speak to the data thing, the data is a challenge. There's a reason their tagline or logo is Ocean Insight. It's about insight into the data. It's about the interesting information. I get where you're going with your question. It's a challenge. It's also the big advantage of robotics, right? Robots offer the capability to hoover up enormous amounts of data. But then, like you say, you have to process it. You ideally want to process it as close as possible to where you're collecting the data. The example I always give here to think about people is it's kind of like my, in 100 years' time, we'll not be sending as many people offshore example. Think of the extreme, right? The extreme is the robot that just emails you the PDF survey report. The engineer just signs his name to a job done, right? That's very little data you need to think because you've pushed all the intelligence. And again, to call back to your earlier question, that informs what we develop. We're always looking to push that intelligence out a bit where we can, make it easier to get that useful information back live.
And Anthony, I guess that data and digitalization piece is the other half of the Stay Ashore program, the robotics side of things. So I know we're straying off robotics slightly here, but I think it is all part and parcel. And so what kind of things are you looking at there?
And I think as kind of, as I mentioned, I think that opportunity there is the value you get from that data, and it's taking that and kind of informing your decisions. I think it's having that better planning, better view ahead to say, well, actually, with this data in, we can get the valuable things to then plan better for keeping people onshore. Obviously, the Stay Ashore program is quite literal. It's to keep people onshore as much as possible by using digitalization and robotics. But it's also making you smarter in your planning and your you've got that information before going to the asset and you know exactly what you're doing. But I think that's the challenge of the huge amount of data being generated. It's kind of the service around that of interpretation and looking at that data to go, right, that is the right value, that is the correct thing to do.
And so Iain mentioned risk quite a few times in his answer to that question. And I think that plays into this a lot, both in terms of managing risk of assets and things like that, but also the risk of adopting new technologies, which we're talking about here. So how does GE think about whether to take the risk of adopting a new technology? How does it balance those up against the potential benefits of adopting new technologies?
Again, I think it's looking at the benefits of anything that comes through and what we kind of get out of that effectively. But I think as well, it's obviously that challenge of, I think people are naturally resistant to change. So I think you've got to have that kind of mindset to prepare people for change coming, and kind of, it's a lot of your communication around it as well to make people realize that, it is a big change that we're introducing, but it's not it's for the better.
Yeah. So do you think there's an element of perceived risk rather than real risk there as well?
Yeah, potentially, because again, I think if it's the first time you're doing something, especially, it's it's seen as a risk, and you've got to obviously do that proof of concept, get your results, and kind of showcase it to say, look, this is the better way of doing something.
That's an interesting point you make there. It's kind of partly why we have the projects we have with the Catapult. It's about demonstration and showing that stuff works in the real world, not in the lab. Because the way I think you described it, maybe in a slightly more flattering way, I'd say there's a race to second place. No one wants to be first with the new technology. Everyone wants to be the second person. You want to see it works. But then that's partly why we do these demonstration projects, so we can say this works, not just in nice ideal test situations, but actually out in the North Sea, where things are very different. And we kind of think like, you need to offer the benefits, like you said. People will buy innovation once because they've got an innovation budget. You need to see, but you sell real benefit to people. That's how we get repeat customers. Like, they see the benefits for things.
And Sara, I guess you're working right at the bleeding edge of what might be possible, and that must come with an awful burden of proof to show this is working. This has potential. How do you manage that?
We feel that one of the objectives of our project is also to show what is possible, and that a fully integrated solution could be used for real. So we really don't focus much on using that robot or the other robot, but to show that this comprehensive solution can be deployed in the real world. So this is why we work a lot with many companies, and we work with the Catapult, and we try to do a lot of demos and to involve the public as well, because I think we need to raise awareness of what is possible, so that, as I said, like, people could trust the technology more and more. And this issue of trust is always there. Like, even I remember when I was working at NASA, a lot of the engineers were not trusting the AI and autonomous technology. So we had to really have a lot of time in developing a good interface, a way in which the operators felt in charge of the mission, even if the rovers were out there on Mars and they were in California. So,
and I guess it's always important to do useful innovation that has an end goal, an end customer, a kind of a real world purpose, if you like. How do you make sure that you bring that into the work that you're doing? How do you make sure that you get that industrial buy-in, inputs when you need it, kind of functional requirements? That must be a challenge at times.
Yes, it is. I try to only take on projects in which I also have industrial partners and stakeholders involved. And so the first phase of the project is always knowledge elicitation. So go and talk to the stakeholders and understand the real pain points and what can be done with robots that cannot be done already. So really, I think in this dialogue with the stakeholders, you can create value and not just create the next interesting piece of technology that's not is used in the real world. So I think this dialogue is very important.
And Iain, at Rovco, you take an ROV survey and then you add layers and layers of technology and added insight on top of that to provide more value to your customers. When you're approaching a customer to see whether they're interested in doing a traditional ROV survey through to a more all singing, all dancing one, how do you find their appetite to trying these new technologies, and how do you try and sell those benefits?
Yeah, it's an interesting one because it's something that is shifted with time. So, I mean, we can kind of look at expectations in the industry, and Rovco's a relatively young company, but we've seen shifts even in that time. So we start off where the tenders are going out and it's traditional video survey is what's requested, and we kind of say, well, we can also do this thing, and the traditional ways of data delivery. For example, we've had customers who've required that we post them paper charts in the mail. now say it's, well, at that time it was 2017, but now it's 2019. We shouldn't be posting paper or even hard drives in the post. They're still very common, and that moves us to kind of online data delivery. And it's, I kind of mentioned it earlier, you kind of often you have to show people might have some innovation budget to try the new thing, but really you need to show that, yes, we can deliver the old thing and we can deliver on top of that. That has some added advantages. And then we see shift in the industry. So we have seen tenders come out where they've specifically required 3D models to be built of the structures subsea, which is something that we do. And that's obviously great for us. And that's because in that particular case, that customer had that from us before and said, yes, this is actually something which has value. When it comes to what you were saying about you need to show people the benefits. So in some cases, the benefits are quite clear. In some, they're less clear because it's a change in the ways of working. I mean, if in some cases, the benefit are you can do something with a robot that previously needed a human for. And that's quite a kind of clear safety case if you can show that it works. In some cases, it's about metrics and reliability. So it's not, you might previously, for example, estimate the size or depletion of an anode or a gap in something by someone an expert looking at video and estimating, whereas we can provide precise measurements, and that's quite a compelling thing if that's the actual output that you want. And then you kind of go into sort of slightly different benefits, which are things like the delivery of our data with an online platform rather than hard drives or paper in the post. And that's maybe a change in the way of working for our customers. So that's a bit of a harder thing. But to some extent, I'd say for us, yeah, it's that that first customer might not be external. So, I mean, in some ways, we have a huge advantage in that we deliver the service and we develop the technology. Mm-hmm. So, if you like, if I say, oh, I've got this great new technology that will let you do a better survey, it's not an external customer, it's our own surveyors doing the job, doing the regular work, showing that we can use our technology for them to do their regular work better. We can get stuff in the sea, tested for real, doing real work sooner that way. And then, you can show that advantage. So I guess it's, to some extent, you kind of don't have to for some things. And yeah.
And you mentioned the safety case there, and I'm interested to get everybody's thoughts on regulations and the regulatory environment. And I think a lot of the offshore regulations do relate to health and safety and things like that. Do you think that will push forward the adoption of robotics, or do you think that actually the regulatory environment isn't quite, the technology is developing faster than the regulations allow for? Do you think there's any conflicts there?
I think the regulation, obviously, we're all affected by it, although not working directly with it. But I think regulation is there for a reason. But I think it also kind of creates opportunities because you're working to very specific items, like you say. If it's looking at the health and safety, you're building something to kind of work to that and ensure that's being done. So I think, it's kind of we all have to live by it, but I think it would be an opportunity rather than something that can hinder.
Mm-hmm. Yeah, I mean, I absolutely agree. I think regulation can drive change. I know we've done pieces of work where I've seen data from previous inspections, and it's been divers in places where I wouldn't want to be. And we're doing the same thing with robots. And I think in some extent, this is jobs that people are carrying out that are clearly very dangerous, and you just think, sometimes you find out a person is doing this job and you think that a person shouldn't be there. That's just not a safe place for a person. So, but in some cases, the regulation can't be there to, say, prohibit a person being there because there isn't the technology. So in some places, there is this gap and it's an advantage. In some cases, I think subsea, especially, I think about, because it's the area we work in most, is in a really good place. There's a really clear safety case, right? Don't want to put people underwater as much as you can avoid it. You partly want to get people onshore, like it's partly it's economic efficiency, but partly also safety, right?
Yeah.
It's that as well. And when I talk about safety, it's always worth mentioning. I always think about there's the safety of people, but there's also the safety of the environment. A lot of it is about this as well. It's protecting the natural environment, protecting the seabed when you're building, things like this. And in some ways, subsea robotics leads the way, because I mentioned a CSO in a subsea robotics company, and someone that doesn't know the industry goes, "Oh, cool, robots." And I go, actually, no, robots have been used subsea for tens of years now, right? It's an industry which is well ahead in use of robotics and the regulation around that, far more so than, say, drones, I'm sure. The new thing is making them smarter. And I think that's an easier step to take than the step of getting the robots there in the first place, which has already been taken.
And I think there is going to be this iterative introduction of robotics. It's not going to be all of a sudden, like you say, they've been used subsea for tens of years and they've grown and progressed and developed as technologies over time. And I think for the foreseeable future, there's always going to be robotic operations in cooperation with human-led operations as well. And I suppose there's going to have to be that element of collaborative working between humans and robots for the foreseeable future, until that picture Iain painted of 100 years' time when it is all unmanned operations. And there are challenges there, aren't there, around humans and robots working together?
Oh, yes, absolutely. It's a big challenge. So in our project, Memory, we really put a big focus on this, because when I started working on extreme environments, I thought that it would be quite easy to introduce robotics and AI, because it's kind of an uncontroversial case, right? Because these places are dangerous. And so I thought, operators will love that. But yeah, as I said before, I then discovered that there is some resistance, and there are a lot of people who actually take pride in doing a dangerous job, and they like what they do. In the end, this is what they've chosen. So really, for us to convince these people to use robotics, it's a matter of gaining excitement and trust. And I think this can be done with a good interface between the robotic system and the human operator. So in our future development, we think of, for example, a virtual twin, so that the human operator is onshore, but getting a lot of data, we can kind of reconstruct the environment that is offshore. And so the operator will be engaged as if was there, but in fact it is in a safe place. So, but clearly this is quite challenging to develop. So in my particular focus in my research is to create a joint deliberation between the robot and the human operator, so that they are both in charge of the mission. Mm-hmm. And so this planning technology needs to be able to, be inspecting, interrogated, and changed by a human operator. But also there is this element of how you present the information and to try to really immerse the operator in the actual operations that are performed by robots offshore.
Yeah, I think I mentioned earlier in terms of how we're talking about deploying camera systems first, you can work with humans and measure, and then it becomes the core of an autonomous system. I think it's a gradual thing, partly. And I think sort of the semi-supervised autonomy is a key thing. It is the human working with the machine. It is, in many cases, it's kind of oversight. In some ways, the technology is maybe not removing the human, but moving the human, right? Getting them onshore rather than offshore.
Yeah, I think that's the key.
And changing the kind of application of where the intelligence is. So if I consider about processing video survey data on our online platform, well, you might still want that surveyor who knows exactly what they're talking about to look exactly the right things, but they don't want to be skipping that 5 minutes of deck footage at the start of every video. They don't want to see the bit where the robot wasn't pointing in the wrong direction. That's, that's part of their job, but maybe not the part of their job, if you see what I mean. So if the machine can then just show them, oh, hey, here's the bits you really want to look at, great, right? It's, and in some cases, it's moving the people, it's moving them onshore. And for some people, like you say, they take pride in their work, and the offshore uptick on their day rate, which is nice for people too. But for some people, it's nice to be home every day with their families, and that's a different incentives for different people, and not be out of the boat.
And I think these valuable skill sets that offshore technicians have, as you say, they're going to be redeployed.
Absolutely, yes.
Because that expertise in understanding the problems that occur on an asset, whether it's below water, above water, that knowledge is still going to be crucial in understanding the data that's coming back from the robotics.
Yeah, I think that's it. You're getting more value out of your technician. Again, we're looking to take away manual and repetitive tasks. You spend a lot of time tightening bolts on a turbine. That's a lot of man hours that could be used elsewhere, kind of in a more valuable service that you're performing. So I think it's kind of looking at that as well, of where the value is. And with the skill set, I think that's you're making a more highly specialised technician.
And you mentioned the kind of bolt tightening there. So GE, I know, recently ran a couple of innovation challenges around generator shoe bolt tightening and blade repair, both of which had a robotics focus.
Yeah.
So clearly, though, you see that there's lots of opportunities for robotics in wind turbine service and maintenance. Are those the two key areas for GE, or do you see other areas as well?
I think that's in the future. Other areas, obviously, the kind of focus of those challenges, which we ran late last year, were blade maintenance. It's obviously, again, it's playing into the safety factor of people hanging on ropes. And again, with the bolt tightening, it's a very specific area that requires some rope access as well. So again, it's looking at that risk element of people hanging on ropes and taking it away from that to then could we automate it with robotics. And obviously, it was quite an interesting process going through that with support of the Innovate UK. Obviously, first time I'd been involved in that type of process, so it was quite interesting from the application to pitch days with companies and then moving on in further discussions, which we have ongoing at the moment.
It's interesting you mention, you're talking about more specialist skills for in terms of what's needed. Whereas I kind of think in some ways the transition, because it won't be a sudden change to more robotics and autonomy, but the transition is driven by people with more sort of multidiscipline skills. So I think about, at Rovco we have surveyors and RV operators as well as the computer scientists and PhDs, and they're working together, and this is kind of key. And to sort of enable this transition, then you have it's someone who's maybe they've got the skills in the RV piloting and they're learning the skills in the autonomy and the things like that, so they can understand both sides to, enable that transition to happen sooner. And from the other point of view, I have software engineers who've gone off and done their offshore training so they can safely go out and stuff. And not many software engineers get a chance to practice escaping a helicopter comes in the sea. So it's a bit different. So I think multidiscipline skills, it's an additive thing. It's people with existing skill sets already performing these jobs, gaining additional skills in different complementary areas that will enable this transition.
But I think that's where the value comes in, because I think if you have a person who has, like you say, an experience in the computer and AI side, and then you have them with offshore experience as well, you're making them a more valuable asset, and that's kind of
the other way around it.
Yeah. So I think it's the things like that where you have the multifunction is the value you add to the kind of the service effectively.
And so one side of the university is clearly research, which is the side you focus on. But the other side is training and skills and education. Are you seeing more and more budding roboticists and computer scientists coming through? Because clearly there's a huge potential for people to take very highly skilled jobs in this area.
Oh yes, so we have seen an increase in the number of students in computer science in general, but especially in AI and in robotics and machine learning. So we are offering, for example, Royal Holloway 2 masters, one in AI, one in machine learning. We have so many applicants, and clearly a lot of new jobs are around this area, so we really need to train people to do this kind of job. So it's an exciting time for university.
And Iain, do you, as a rapidly growing kind of technology focused company, are you managing to identify the right kinds of people with the right kind of skills to join your team?
Yeah, so I think we do quite well, partly because it's an attractive industry to work in at the moment, right? I mean, AI is a trendy topic in general, but this is an industry which is in the UK. The UK is one of the best places in the world to do it, and it's applied as real work. Like, it's real robots doing real work. That's quite an important thing, and for a lot of people, that's very attractive. It's not some nice lab thing. It's actual real work, and so from some extent, yes, we attract people because it's a cool thing to do. On the other hand, there are skills which are definitely not as readily available. Like, for example, there are not many, if I say field roboticists, so that means someone that works on robotics actually out and about, not just in a lab. That's rare, very rare people. Very few people have done much field robotics because it's only been a thing for a handful of years, a couple of handfuls maybe, depending. And so that's quite rare, but it's maybe not necessary, because a lot of it is you can bring in skills from other areas and it can transfer. So it's kind of, yes, it's hard, but we manage because it is an attractive area to work. I mean, the thing that makes the skill shortage is also the thing that makes it an attractive area for people to retrain. So we see experienced software engineers, for example, who have taken upon themselves to learn about AI and how they can apply that. And then that is valuable because they bring a lot of experience. Or we see from the operations side, people who've worked in operations offshore for many years, and they say, oh, there's this new stuff coming in, I want to get involved, I want to understand it. And, you recognize the existing experience. When we talk about students coming out of universities and things like that, yes, there's lots more people who have done some sort of AI, some sort of robotics. It seems like everyone has these days. I mean, part of it is the applications we get, but it's so yes, there will always be a demand for people, but then if you're doing, I mean, we're fortunate to be working at the forefront of the technology. It is not commoditized yet, so then that attracts people as well. So it's a balanced thing.
I wanted to say that I think it's true. We see a lot of people who come from different disciplines that want to retrain in AI, and that's very nice because they bring their previous experience in other fields and can transfer this in how to develop technology. So that's also a very interesting shift.
Mm-hmm. So we've got about 15 minutes till the Q&A session. I'm seeing plenty of questions coming through on my screen now, which is great. So keep your thinking hats on for those of you watching. And so I guess for the last 15 minutes, it'd be interesting to think about what's possible in this space. So kind of put your crazy hats on and think, right, in 2030, 2050, what are we going to see being deployed in offshore wind farms? Obviously, Memory is a very, very ambitious project looking at deploying multiple types of robotics from an autonomous platform. When do you think that might become a kind of commercial reality in offshore wind farms?
Yeah, so in these projects, just to clarify, we are looking at an integrated solution. So we have an autonomous surface vehicle that is like a sort of mothership that will go to the wind farm. And then we have a team of drones that has to do like inspection of the wind farms. And then we have also crawling robots that are supposed to climb the turbines and do some repairing jobs. And so we also have a manipulator that can do really fine manipulation tasks. So really there is the whole spectrum of robotics and AI. So our goal is to deliver a proof of concept, but clearly to make this reality and make this used by a number of stakeholders will take a long time. And if we think about the interaction with also the human operators, there are a lot of challenges that are common to other fields in AI. For example, the best would be to use natural language for communication with the robots, but clearly, this is a big challenge to really do natural language processing at a level in which there are no misunderstandings, because in extreme environments, this is crucial. So, yeah, there are still lots of challenges
I suppose a lot of people at home will have first-hand experience of that with an Alexa or a Google
absolutely.
Home.
But as we said before, in extreme environments, risk is a big factor. So you really don't want to have a misunderstanding with your robot offshore.
Yes, and their kitchen probably has a better internet connection than the bottom of the sea.
Exactly. So I don't think you have to be thinking too crazily to be thinking 10 years out. I mean, if you think about the lifespan of these assets, these things get built and put in the sea and they're expected to operate for 30, 40 years or more. So 10 years' time, we're still talking about wind farms as currently built. So I think there's actually a really interesting question here is when do we start to see what I think of as affordances for autonomy in constructed wind farms, constructed turbines and nacelles. So to explain what I mean there by affordance is something to support it. So for an example, an affordance for the human that is on wind turbines is you get a ladder up the side of the monopile, right? It helps the human perform their task. So, but at some point we'll start to see, because of autonomy, we'll start to see everything from the turbine to the monopile to the whole farm built differently to enable affordances, to enable more autonomy. That could be garages for resident EVs. It could be other things we haven't even imagined. And I think thinking to the future is an interesting question is to think, much further future, when do we start building wind farms differently because of the autonomy AI? I mean, maybe to some extent you're already thinking about how can we build turbines, how can we run things differently with the support of autonomy. But to actually answer your question rather than give you a new one, I'd say 10 years' time, we're looking at online streamed intelligence. So it's not just about the raw data. It's about getting useful insights that are streamed to you live. Yeah. It's not the raw data. It's multi-agent. It's collaboration between robotics. I mean, we're already delivering surveys to customers where we have drones topside and robot subsea, but it's not coordinated, it's not autonomous, but more autonomy there. So yeah, I'd say
I think that affordance piece is incredibly interesting because you see a lot of legged robots being developed, for instance, that have to deal with steps, and steps are a human construct in effect, aren't they? They're because we have 2 feet that go one in front of the other, and if those steps weren't there, it'd be a much easier task for a robot to move around a structure. So I think there has to be a point at some stage where companies begin to think about, okay, well, how will next year's maintenance team move around the structure, not our current maintenance team?
Yeah, so I know to some extent, Memory Project, you are thinking about how things might change in terms of this integrated vision of autonomy, but I'd say our GE thinking about how things might change when you've got more autonomy. I say autonomy in the broadest sense. It could be data intelligence, it could be actual robotics.
It's been considered, and like I say, it's kind of part of the roadmap and kind of thinking. But I think obviously touching on some of the points, I think obviously a lifespan of wind farm is potentially 30 years, and obviously, like you say, they have steps. If we're going autonomous robots, legged robots is obviously a thing that you have to consider, because obviously the current conditions is what you have to kind of think of. But I think in a way, at the moment, no idea is fanciful. It's just getting that kind of it's shown it works, and obviously thinking about the existing structures and what is there now. But then also the flip side is, I think if we're all due to have flying cars by now, if we believe some predictions from previous. So I think it's also that if anything's possible, and it's thinking about existing structures that are there, and like you say, some of the infrastructure also needs to be there. I mean, internet connection is obviously a big thing if you're wanting to get that information back to onshore, and kind of thinking about that, as well as having a robot that can navigate steps and do the tasks that you've set it to do. So I think that's also a consideration for the future. So that's obviously one of the next steps.
Yeah. So I think a trend that both you and Iain touched on there was that integration of different systems. Do you think that's probably the next big step? We're seeing individual robotic systems being deployed, but having them come together and act not necessarily as one, but in a coordinated manner.
Yeah, that's for sure. Because, for example, in memory, we are not really focusing that much on the single robot, because these pieces are there already, more or less. But the most of the work is about the coordination between the different robotic systems and how they perform a job together to achieve a shared goal. And there are a lot of challenges, because I don't know, if you have a crawling robot and a drone is delivering this robot on the blade, you don't want to drop it, right? So you have to have a lot of mechanisms to.
Yeah, I think Anthony would be very upset if his blade got damaged by a falling robot.
Exactly.
Not just me, obviously the owners. But I think that concept of the more things a robot can do, the more value it has. So I think that kind of thinking adds a lot and makes a more attractive proposition to say, well, it's not just doing one thing, and you need multiple kind of robots going off in different directions, doing different things. He has one system that can do that multiple tasks you've set.
Yeah.
So I think kind of that consideration is kind of where the value is added.
But it's interesting when you think about this integration, the collaboration. There's a kind of, we've been talking about the technology, but there's quite strong business reasons why you might start to see this. So if you consider a risk-averse industry procuring services on their wind farm, say that's generically what's happening, you get to a state where, in some respects, I'd expect to see some sort of collaboration encouraged, because do you want to buy the autonomy and intelligence service from someone that already supplies you and has a proven capacity in one domain moving into another domain, or do you want to have a completely different supplier? It's maybe an open question there, but I mean, I can see there being strong business reasons to go for integrated collaborative approaches, because you take something that you know and understand in one restricted domain, so you maybe apply robotics in some narrow area where you can make the safety case, you can make the business case, and then you say, you expand from there. So you kind of naturally, as a result of the sort of business realities of this, end up with this collaborative system, perhaps. I mean, I kind of think of a corollary where I think a lot of autonomy and technology adoption is not driven by the technology, it's driven by other factors. So my favorite example of this is self-driving cars. I fully believe that'll be driven by calling your insurance company for renewal, and they say, will you be driving the car yourself, sir? And you say yes, and they suck through their teeth and it costs you more. But I mean, it might come down to that, because a lot of the issue around wind farms and their construction and maintenance is around risk on the finance required to build them. And if you can drive down that level of risk with better data, better insight into the condition of your wind farm through the use of robotics and autonomy, then the finance becomes cheaper, the wind farm becomes cheaper, the cost of energy to the customer at home becomes cheaper. So, I think the future, there is a technology which is necessary for the change, but the drivers might be business drivers in some cases.
And so autonomous systems are, by their name, autonomous. They make their own decisions to varying or lesser degrees, depending on how they sit on the range from kind of automated to fully autonomous. And you can show that an autonomous system makes the right decision once fairly straightforwardly. You can ask it to do something and track its progress. How do you show that it does the right thing every time and that it's always going to make the right decision? Because that's a key factor when a customer is considering risk.
So personally, I developed this AI planning technology that is model-based. So it's very different from machine learning that is model-free. So in a way, we use mathematical optimization and logic. So if you have a plan, you can really demonstrate that starting from this initial state and going to this goal state, this was the best path. And then clearly maybe you have to diverge a bit from the best course of action, because I don't know, there might be weather conditions that not allow you to do really the best possible path, but still you can explain why you have taken a different course of action in that particular circumstance. So this is why in memory we put a lot of effort in planning, because it's really unexplainable technology. So the operator can be involved in this joint deliberation with the system, in which the operator can also decide to maybe take a higher risk, but go for the most efficient way to do things, or decide that doesn't want to risk much, and so maybe take a longer course of action that still achieve the goal. AI planning is really explainable technology, and this is why we want to use it in extreme environments, where it's very important that before and after the mission, you can really inspect the system and understand why decisions were made in that way.
And that explainable AI is something a lot of people are looking at, isn't it?
Yeah,
because
exactly.
It helps with that trust issue that you talked about at the start, and will help people to trust the systems that they're buying.
So yeah, I think there's the technology. There's two possible answers to this. There's the technology answer. There's how do you verify and validate and test. These are all different things. These autonomous systems get proven correctness. But then there is also other ways, if you consider the whole system, how you can mitigate the risk and avoid the problems. And this is like, it's easy to think, oh, we need new approaches to new technology, but also old approaches, like the ways that you mitigate risks to safety. You ensure that harmful cases just cannot occur. So to give a sort of simple example, you can imagine a robotic intervention task where you have the problem, well, what if the robot goes wrong and knocks into something and breaks the export cable, say, and you've now unplugged your wind farm? That would be a very bad thing and very expensive, so we don't want that to happen. And then you could say, well, I'll verify and validate my system and prove that I'll make no bad decisions and so on. Or there's maybe an alternate approach where you just say, well, if the robot doesn't mass over a certain amount, then it just doesn't have the physical energy to cause that thing to fail. You can have these layers of protection, and they're not all around the technology. Some can be around the engineering, some can be around the ways of operation. So you kind of say, and there's arguments both ways for this. I think an interesting one is, if a task is in some way safety critical, does that mean it absolutely should have a human in the loop? Or does it mean it absolutely should not have a human in the loop? In some cases, because you can, and you can come up with examples either way, where you think, oh no, a human is unreliable in this decision case, or in some cases where the human absolutely must be involved. So I think the answer is you consider the verification and validation of the systems. You also consider how they're operated, how they're deployed, the whole environment. And
that example you gave there, it's almost just common sense. A 3 kilogram drone is going to make very little impact, even if it does crash into a 400-ton offshore structure. So as when you're thinking about these new technologies and the verification, validation, testing, demonstration of them, what do you need to see before you're beginning to get interested in looking at these technologies?
Yeah, so I suppose it's obviously we kind of see different things at different stages. So we see things, I think if it's a good idea, it's what support could GE potentially give if we kind of buy in. But also I think it's proof of concept. So obviously a demonstration, as we mentioned before, it's showing that it doesn't just work on paper. There's a real life example, and it's kind of taking that proof of concept and then applying it offshore to give confidence. I think it's building confidence throughout the process to say, yeah, right, on paper, great, works. We've had a demonstration, right, great, we've seen it in the real world. Now let's give it into the, controlled conditions, should I say, when it's a demonstration, but then into the real world, and kind of you're building up that confidence and you're learning at each stage to feed back into the loop to give you that confidence to move forward.
And that's the same approach that you've been taking as well, isn't it?
Precisely. I mean, we had the explicit goal of the projects of the Catapult, the demonstrator projects, to show the proof of concept of the technology, the proof of the technology in a representative environment, and the proof in the real environment. So we've gone from testing in your docks at Blythe, where you can get some really nice metrics on the system because it's effectively a bit of the sea that you can drain, and we can use standard survey LiDAR and get a known benchmark to show the accuracy of our systems. And then we go on to your offshore metmast and in North Sea itself, alongside our activities apart from that. So yeah, it's this demonstration is important. It's you talk about deploying in controlled environments. Again, this is what I was saying around controlling the risk around it. And for us, we see this kind of as absolutely key when you're doing something new. And it's part of why we do the operations and the service provision as well as the technology development. Is it means we can control how technology is introduced and deployed to make it safe, to make it palatable for an end customer. And I think in some cases it might be driven by an absolute need. I mean, I see the cost of energy that has been promised for future developments of wind farms and think there is absolutely no way this is getting met. If things are done the current way, there needs to be new ways of work, there needs to be safer ways. So in some ways, it maybe just needs to be better than it is currently. Like you maybe can't aim for perfect, but then you get into interesting questions like how good is some task you want to replace with autonomy, how good or how safe is it or how reliable is it currently? And oftentimes there are not numbers for that, right? It's an interesting thought experiment is how much better than how good does something need to be to replace the human? How do you trust it? I mean, an easy example most people relate to is autonomous cars, right? How many accidents per million miles does an autonomous vehicle have to have before you trust it? And you have those statistics for humans and the computers are already way better, but people don't trust them. That's not just enough. There needs to be something more there. And I'm sure you could talk for a long time on issues of trust. It is a really complex issue. Yeah. I mean, maybe it is one of the most important issues in adoption for these technologies.
Well, that's been a fascinating hour of discussion, and I think it's now time to get some questions from the audience at home. I've got lots of interesting questions coming in here, but please do keep them coming. We've got half an hour and we'll get to as many as we can. So I'd like to kick things off with a quite high-level question here, and that's how do the panel feel that robotics can contribute to net zero targets for 2050? So this is looking much more broadly at how, and you mentioned that robotics can play a role in protecting the environment.
Yeah.
How do they play a broader role in net zero? That's from Lee.
Yeah, so I can start on this if you want. There's a few different ways. Part of it is around protecting the environment. The kind of directly, it's inspecting the environment, showing that, maybe doing surveys of wildlife and marine growth, things like this. And that's just monitoring, that's not really active. The active thing is a lot of the driver for vessel size offshore, not all of it, but a lot of it is around the number of people you need there. If you can take people off the vessels, if you can have smaller, cleverer robots doing more, then you reduce the size of the vessels and you reduce by order of magnitude the amount of fuel burn to stay there. There's quite a strong economic incentive along with the environmental incentive there. Driving down the cost of energy, like it kind of links nicely onto my point about the cost of energy. If you can inspect, if you can maintain, if you can construct wind farms more efficiently, then you drive down that cost of renewable energy sources, you make it more viable. So I think, from the very direct of just smaller boats doing more work to the very indirect of this reduced, I mean, I could say if you reduce the cost of the finance on building a wind farm by better understanding of the data and the risk, that drives down the cost of renewable energy and contributes towards that goal. That's quite an abstract impact of robotics. I mean, so I guess my answer is a cop-out. It's everywhere.
Unfortunately, I agree. I think it's that the analytics and automation does drive down kind of what you're doing, your planning as well. It makes you smarter, it makes it better. And I think, again, that we use a lot of kind of fuel with vessels. So again, keeping them kind of in docks and people on shore, I think you naturally drive down an environmental impact by the use of fuel you have.
Yeah, I think we are aiming at making operations more efficient. And so, for example, in our project, we are developing a camera that can do inspection without shutting down the turbine. So in this case, for example, you don't lose that time. And even these little changes can make a difference in the end.
So I've got another question here from Terry. So he's saying that unmanned systems take an awful lot of people to operate and maintain them. And so what are the panel's thoughts on the training of future engineers? We touched on this earlier, but do we have any more thoughts on that?
I suppose this is your skill set and skill transfer. It's just ensuring that you have the people there with that skill set to maintain. So you're kind of making people look at different things, I think, and kind of having that skill set, I would say.
Yeah, I'm glad that this question come up, because there is a lot of debating right now around the fact that AI will take away all jobs. But I think it's quite the opposite, because when you deal with robots, you realize that you will need to
machines themselves.
Yeah, exactly. You need to take care of them, and you need to program them. You need to improve their way of operating. So I think there will be a transfer of jobs from some areas to other areas, but this is also why the UK is really investing a lot in training people in AI and robotics, because these are the skills of the future. So, for example, the UK has created these CDTs for PhD students to learn more about these topics. So I think this is a very good way to prepare the country for the next steps.
I think this one's perhaps for Iain. So this is from Dorothy. What about subsea recharging points? Is the technology keeping up with autonomous underwater vehicle developments? Is that something that you're looking at as part of your roadmap longer term?
Yeah, so I won't talk in detail about our long-term roadmap. I'll talk generally about the industry. There's a lot of different approaches. Different people are trying different subsea docking and recharging things. I know you've had some in testing and projects in your docks at Live, for example. And it's often not just recharging, it's about comms, but recharging speaks to a kind of key point of all robotics, which is always battery power. That is nearly always the limiting factor. It's not how smart the robot is, it's how long it can run.
So it has to be smarter.
So it has to be smarter, yeah, because you absolutely can drive down energy use and energy requirement by having a smarter robot. I mean, you can consider in the extreme case, the robot goes exactly where it needs to be, looks at just the thing it needs to be and goes back again, needs less power. If the robot is smarter compared to swimming around for a long time. So I can't answer directly the specific question on is it charging? I mean, it's kind of what are the charging requirements in the robot depends on what task the robot is performing and for how long, and how frequently, and how many robots. So I suspect it's a kind of case by case thing. Yeah.
Did you want to come in on that as well? Or? So this is from Alex. Are there ways to quantify the value of robotics? For instance, how can they reduce operational costs? What's the break-even point and other benefits? And I know some of my colleagues at back at the Catapult do a lot of work on this in terms of the cost modelling of new technologies. But is there anything that you'd like to come in on that? How do you look at the business case of new robotics for GE?
I suppose it depends on the task they're doing, and it's looking at what that does. What are the benefits? So again, is it reducing the risk? Is it moving people onto different tasks so you get a smarter kind of plan when you're offshore and utilising the time better? So I think there's lots of modelling goes on to kind of give you that look ahead to say, well, yeah, let's do this and let's move forward with it.
I think it varies, and in some cases it's quite easy to quantify the cost, right? In the sort of first order impacts of I can do a job more efficiently with less people. If I'm paying one less day rate on a boat, I know exactly how much that costs. As in offshore operations, everyone knows exactly what everything is costing per day, right? Every bit of kit's got a day rate, every person's got a day rate, so you can quite easily. But that's kind of your sort of first order impact. The second order impact of it is, if I have this higher quality data, can I perform less frequent inspections? If I have this integrated inspection, can I send one boat to do topside and subsea rather than two boats, and then get some efficiencies there? And then if I think much, much further out into the future, I say, if you can ensure you've got this higher quality of data, this higher understanding of your asset, would you build the asset differently? Would you use thinner steel in the monopiles or something? I don't know. Would you construct the nacelle differently if you could have a different maintenance regime enabled by robotics? And that's a much harder question to answer, but that's probably where the big money is, in these second order cost effects, the higher quality data, the different ways of operation. So I don't have an answer, I just have another question.
There's been a lot of that today, but that's okay. So this is perhaps another one for Anthony. From Carl, all this talk of subsea, what about robotic operations in the nacelle?
I think it covers kind of some of the tasks we're talking about of bolting. I think that applies kind of everywhere in a turbine. But again, I think it's robots are being considered for kind of other operations, whether that's in the cell or other parts of a turbine. So yeah, it is being considered.
Okay. So Richard's asked, what can we do now to improve efficiency of manned operations and facilitate the phased introduction of autonomous systems to support those manned operations? So that's going back to the question we had earlier around the collaboration between humans and robotics. So how can we use autonomous systems to supplement and improve the efficiency of traditional manned operations?
So I guess, for example, engaging in a dialogue with companies or academia, anyone who is involved in this creation of the new generation technology for offshore wind farms is something very valuable, because it's really difficult to create a model for the robots, because, for example, I am not an expert, right, in offshore wind farms, so I need to learn from experts. So this engagement with people who try to create the technology is crucial, and trying to really transfer the skills to these people so that they can do robotics that makes an impact. So I see this as a very important step. And then clearly there will be a phase in which robots are used together with human operators. And so the feedback from people involved in these mixed operations will be, again, another important aspect.
I think I could give maybe a practical and slightly more direct answer to that, which would be think about the data and think about your data, because at the moment, primarily the chain is human-controlled robotics collecting data processed by humans, and many owners, operators, etc., will have historical data to this fact. So maybe the route forward is to think about what, as the question asked earlier, what questions would you ask of your data that you can't answer? Can you look at processing historical data, for example? That's something we look at, and to get new insights there, because it's a lower risk entry, is to say that data I've already got, is there some additional value from that asset that I can get out of it? And then maybe eventually that leads you into this future of live. And, is it the autonomy as an add-on? Maybe. I mean, if you consider the autonomy isn't driving the actual robot, if you've still got a human at the wheel, then there can be autonomy in lots of other places, alongside, not replacing. And think about that areas in which it can be supplementary rather than replacing.
Yeah, I mean, for example, with planning technology, what I have seen even in other environments, disaster response, for example, is that it's very useful for a human operator to inspect a plan that has been created by a computer, because usually the computer tries to optimize some metrics, and the human operator can have new ideas based on what it sees. So it could be initially really a joint deliberation in which the machine and the human operator kind of help each other, instead of one replacing the other.
So we've got another question here about data mostly. So from Farah, can you speak a bit about innovation in cybersecurity related to robotics? Do you see these risks or perceived risks as a barrier to adoption? So cybersecurity, making sure that data is safe.
So I can talk about this in terms of what people speak to us about, because people are concerned about this. I think the kind of short and easy answer is it's no different to any other industry. I think any industry, not just robotics, has questions around the security of data and where the data is held, especially post GDPR. A lot of other industries. I mean, there's less personally identifying information on a wind turbine. You're not going with people, but these are not unsolved problems, right? It is for a lot of companies and a lot of business, for example, have made the transition to on-premises processing of data to cloud infrastructure, which has a lot of the same barriers, a lot of the same problems are there, right? The cloud infrastructure, you have this problem of the data is somewhere else, it is not here in front of me. There has to be communications links. These may be unreliable. It's the internet we're talking about. So I don't know that robotics necessarily introduced any new problems. I mean, maybe there's a small risk if you have a risk of someone kidnapping your robot and getting the robot off it, getting data off that. I mean, that could be a real risk depending on where you're operating and what your risk model is, but then that is something covered by a risk assessment as normal. That's not I'd hope if you're worried about your robots being stolen or kidnapped, you may also be worried about your staff who are currently doing the same job. So accidental loss is maybe more relevant there, but again, the accidental loss of a robot and the risk of what data may be with it, is it that different to the accidental loss of a laptop that gets left on a train? Can you use a lot? So I think, I don't know if there's anything necessarily new introduced by robotics. I don't know if anyone else has any thoughts on that.
No, I think it's kind of echoing what you said. I think it's a known consideration, and it has to be thought of, because obviously you're processing data and it has to be done in a way that you are protecting it with, where you can protect, obviously, and that's a consideration that's kind of ongoing already.
I'd say that you said it has to be thought of, and yeah, that is absolutely right. You absolutely have to think about it. It can't be an afterthought. It's like safety. No. I mean, safety of your people, safety of your environment, safety of your data. It must be one of the first things you think about. And like that's something we think a lot about. Like, how can we secure the data from the light coming in the front of the camera system to hitting your desk or your iPad? Like, you want to ensure security all the way.
Okay, so this is a question from Lee. I'm interested to hear from Anthony as to the robotics technologies GE are looking at for the development of its next generation turbine, the Haliade-X. So we touched upon briefly that you've been looking at blade inspection repair and as well the generator shoe bolt tightening. What are the other core areas?
At the moment, they're kind of the core focus is those at the moment. As I say, we ran the robotics challenges. Obviously, as I kind of mentioned, we've got the technology roadmap. They're currently focusing on the installed fleet as is at the moment, but obviously the idea is to potentially roll that out on the Haliade-X when that becomes operational. So yeah, it's kind of ongoing, and we're considering kind of the next phases of what we're looking at from a robotics point of view. As part, like I say, I've mentioned it previously, as part of our roadmap, it's kind of baked in to say, right, these are the next things we're going to look at.
Okay, so Alan is interested to know about verification validation in the context of new and modified systems. So you can validate and verify a new system, but how do you manage any changes that you make to that system and whether it's still going to perform as intended? Do you have to start from scratch, or are there processes you can use to mitigate that risk?
If no one else is going to take it, I'll mention it. I don't have a concrete answer to this. I think a lot of this is, we mentioned regulation earlier, but there's kind of alongside regulation, you get standardization. And this is somewhere where I think the could or should be. I mean, there has been many other industries have areas we can look to here. You can look to aerospace, you can look to automotive for standards around how you do these things. So yeah, I don't have a good answer here, but I imagine the actual final answer will be standards to which you have to adhere to be able to do these things. A lot of it, I imagine, I mean, it is an interesting question, because when it comes down to a lot of things in modification equipment and things like this will come down to, you know, a competent person has to sign off on the thing you've made. Right? That might just be welding an extra bit of deck on or something, or whatever it is, some modification. But when that is, I'm changing how my machine thinks, then who signs off on that? Can you sign off on that? And back to this issue of trust and transparency, right? And in the systems. So can you prove it? Maybe in some cases you can.
Yeah, I mean, as I said before, I cannot really answer for robotics, but for the AI side, our choice of using, for example, mostly planning for decision making instead of black box machine learning tools comes from the fact that planning technology can be verified, because, as I said, it can be. You can create a plan in advance, and you can inspect it, and you can verify against certain properties, and then only when you are confident you can ask your robot to actually perform it. And even during execution, you keep monitoring the execution of the plan, and whenever you see that there are some big discrepancies, you can just ask your drone to go back to the boat, or try to alter the course of action in such a way that safety is maintained. Mm-hmm. So in using this model-based technology is very useful to really ensure that every course of action can be validated and before execution.
And I think, I just add to my point, I mentioned other industries we can learn from, but I think offshore is an industry that has a lot to offer and to in some ways lead the way for a lot of these problems, because you mentioned earlier, if you've got a 3 kilo drone flying around, there might be literally, you may be able to deploy that in a situation where it is impossible for it to harm. And so you have a much, in some ways, easier. There's a lot of things that make it harder, like the weather and environment. It is an extreme environment. But in some ways, I can see how offshore and subsea robotics could lead the way in a lot of deployment of autonomy. Yeah. The safety case and the verification validation, if I wanted to fly a 3 kilo drone in central London, where we are today, that has a much more problematic when that exact same drone could perhaps operate in a wind turbine with no risk.
Yeah, I mean, a wind farm is a very structured environment, right? And so, in a way, you have a more like clear task than, I don't know, driving a car in, I don't know, Rome. So I think, yeah, as you said, we can lead the way.
So I've got a question from Niels here about the responsibilities for the work that an autonomous system undertakes. And I suppose my instinct is that it remains the same as if a human operator was undertaking a task. But who is responsible in case a robot damages an asset? What's the kind of view of insurance on this?
Don't work in the insurance sector, so I'm not too sure. But I suppose that's kind of one of the discussions you'd have during kind of your tender process with the owner operator to say, look, this is a service we offer. The responsibility lies here, and that's an agreement you would come to, would be my understanding. So I think it's a kind of a negotiation point. Because obviously, if it is a service you offer, you have to kind of have thought about it and say, well, this is a kind of the standard impact that we see, and that's the kind of the points we are offering.
These are the risks.
As
our service provider.
Yeah, so I think it's a negotiation point, I think, for me.
A contractual thing.
But this is not different, again, from other industries, right? Like from self-driving cars, or even when you have an airplane with an automatic pilot.
But then I would flip it and say, like, the question is viewed as, like, the question's been asked because this is a negative point against the adoption of robotics. But at some point, I reckon you get a tipping point where you say, who's going to verify that that person is reliable? I can give you the statistics on their system. I can tell you how much it will, what level it will perform to, the accuracies it will have. And then at some point you say, well, I'm going to have a person do the job. And someone goes, oh, hang on. That's not the same.
And I think, that there's a very real risk that a human might damage an asset as either a human or a robot. So that there's still that potential of a hazard or a risk there. So there's no real change there by moving the who is undertaking that task. So we've got a question here from Steph. How do we ensure that the UK stays ahead of the curve in robotics in harsh environments? At the moment, we're at the forefront. How do we keep that lead on the global scale, on the global stage?
Well, education, I guess, is key. So as I said, the UK has invested recently a lot on educating people in AI and robotics. So I think this is a very good step. Creating new programs. And now there are, for example, talks about creating even undergrad programs focusing on AI and big data. So I think for sure education is one of the main points.
Yeah, and I'd say education also, if the future is driven by more technology and deployment of autonomy, then that will be supported by some funding. Like the work we do with the Catapult, which is partly supported by Innovate UK, that helps us bridge that gap between technological proof of concept and real world demonstration, which is necessary to lead into convincing end users and operators to adopt the technology. So I think government funding definitely helps there and can be proven
the right environment for innovation to come about.
Yeah. And regulatory environment as well. Yeah. So you see, you need to be legally and safely able to deploy these systems, able to test them, and sure, I mean, it's not a problem offshore. I mean, this is one way we can lead the way. There's more problems and hurdles there in drone operations, say, or autonomous vehicle operations than there are offshore, which is we're very fortunate in. So we have a good environment, but that needs to continue, I think. And to some extent, indirectly, like the incentivizing the auction mechanisms for providing wind energy at affordable prices, drive a sort of economic desire for more autonomy, and that helps as well. So I mean, yeah, it's the direct funding and also the indirect incentives.
So we've got a question here from Andy. What technology breakthroughs, both software and hardware, are required to accelerate progress in this area? And what are the opportunities for UK companies? That's a big question, maybe split into two parts. So first off, what are the technology breakthroughs that we need to see to accelerate progress towards some of the futures we've talked about today?
It's a bit of a difficult one from my perspective to answer, but I think on kind of the opportunity, it's the world's quite a small place in a way. So if an idea is a good idea, it can be applicable elsewhere. There's obviously wind farms globally now, and operators and owners have interests in different kind of regions. So I think if an idea is a good one, it kind of goes global very quickly.
I think all the bits are there at the moment for some tasks. I think that's an easy answer. A more specific one, I think, is increased connectivity is a big thing, because we've talked about this gradual introduction of autonomy and robotics, which is supervised by humans. And if the humans are onshore and offshore, there needs to be some level of connectivity there. And there is in many cases. A lot, if you're close enough to land, you get 3G, 4G, 5G. If there are constellations of low Earth orbit satellites going up now, you've got OneWeb, SpaceX, even Facebook, lots of companies trying to do this to increase connectivity. There are some technological challenges there around, and specifically around antenna that can communicate with low Earth orbit satellites from moving platforms, for example, something bobbing around on the sea. So some of these breakthroughs are coming. Like, we can see them on the horizon, and I would say connectivity is a big one.
So yeah, connectivity is good. Also, I guess, as I said before, this ability to integrate different robotic assets, because clearly each robot has its own specific requirements. So to really manage to interface all of them and work as a team is still quite challenging. Also, battery time is a big factor, because we see a lot of this discussion of and how much a drone can do with this battery time, and what is the maximum weight it can suffer. So this is another big issue. And around the communication with the operators, creation of knowledge from data, so the use of machine learning in this way, and also I guess this creation of an immersive environment is still quite challenging. There are a lot of developments in this area, but to really deploy a fully integrated solution with all these pieces together, I think is going to be the real breakthrough.
Mm-hmm. So for the final question of the Q&A session, I want to come back full circle to where we began the questions on an environmental footing. So Bram asks, do you think robotics can play a role in monitoring movements of birds, bats, mammals, fish, and influencing these movements? So I suppose this is all around how can robotics feed into the environmental impact assessments of offshore wind farms, which is a big topic.
Yes, I guess robotics has a lot to offer in this field. You can imagine that robots can do a lot of inspection tasks in a much more efficient and smart way. So for really protection of endangered species, all these kind of things, I think you can use robotics of different size and shape, and drones with ground robots. So I really can see a lot of potential in this area.
I mean, I think to some extent this is happening already, or is happening now. So I mean, as a company that provides service and develops technology, we have customers who are part of that work. We are reviewing video data, identifying specific marine growth, getting understandings of that for these monitoring requirements. And so we are actively looking at how we can apply our AI systems and our intelligent data platform to analyzing this data, because then this is somewhere where we have a real chance, I mentioned earlier, to look at historical data and see trends. And the advantage of AI systems there is, and you can imagine, even if you like a hypothetical, relatively unreliable AI system, if you know that level of reliability and that consistent performance, and you can get good metrics from historical data as well. So you can look at archived video footage, extract some insight from that, show perhaps proved or meet regulatory requirements that you're not adversely affecting marine growth. So I think there is good opportunity here. A lot of it is about having reliable, repeatable metrics.
Well, thank you very much for joining us today. Thank you very much to the panel. That's been a really interesting 90 minutes. It's certainly flown by for me. So thank you for joining us today, wherever you are in the world. You can find out more about these topics by visiting us on Twitter at ORE Catapult, or visiting our website, ore.catapult.org.uk/robots, for data, project news and information about robotics and offshore renewables. So all that leaves me to say is goodbye, and thank you very much for tuning in.
Thank you.
Yeah.